Hello everyone, in this video we will understand what is bisection method. Before going to the bisection method, we must know what is a root. By the definition, let f of x be real or complex valued function of real or complex variable. A number a real or complex for which f of a is equals to 0 is called a root of that equation. Or we can say 0 of f. Let us make an understanding with the help of a graph of y is equals to x square minus 3x plus 2. This is a quadratic equation with roots as x equals to 1 and x equals to 2. If x equals to 1 is my root of the given equation, then the graph of the equation will definitely cut the x-axis at the point 1. And similarly, if x equals to 2 is the root of the equation, then the graph of the equation will cut the x-axis at the point x equals to 2. Moving on to the next definition, which is intermediate value property. If f of x is continuous in the interval a comma b and f of a and f of b are of opposite signs, then the equation f of x equals to 0 has at least one root between x equals to a and x equals to b. Let us make an understanding of this property with the help of a graph. Let us consider a graph of f of x in the restricted interval of 0 to 2. My function is firstly positive here, and after that my function is becoming negative. Clearly, the function is having opposite sign between the interval 0 and 2. So, according to the intermediate value property, the function will definitely have a root at this point. Other way around, let us consider the interval 2 and 4. Before this point, my function is initially negative. After this point, my function is becoming positive. So according to the intermediate value property, there definitely exists a root between the interval 2 and 4. Moving to the bisection method, bisection method is based on repeated application of intermediate value property. Consider f of x is equals to 0 whose roots lie in the interval a comma b such that f of a and f of b are of opposite signs. Without any loss of generality, consider f of a is less than 0 and f of b is greater than 0. The step 1 says find midpoint of the interval a comma b. M is equals to a plus b by 2. Find f of m. Here f of m can be positive or negative. What actually happened here is, let us consider this as an x-axis and this is my point A and this is my point B. My graph is initially positive and after some point it becomes negative because we are checking at the point A and B only. At this point my function is positive and here my function is negative. So what we will do, we will find a midpoint of this interval, say this as m. And in our case, the value of function at the point is positive. Now, the intermediate value property hold between m and b. But if we take the graph other way around, say, let us consider the graph is like this. So at that point my function here is negative. So in this case the intermediate value property will hold in this interval, that is a comma m. So we will update the value according to the nature of function at the value m. Step number 2 says, firstly, if f of m is equals to 0, then m is the required root. Secondly, if f of m is greater than 0, then root lies in the interval a comma m. And thirdly, if f of m is less than 0, then the root lies in the interval m comma b. In the next step, if root lies between the interval a comma m, then update b by m and new midpoint will be m as m is equals to a plus b by 2. And if root lies between the interval m comma b, then we update a by m and new midpoint will be m as m is equals to a plus b by 2. In the next step, we will find the merge distance, and if that distance is less than 10 to the power minus n, where n is the expected decimal digit accuracy. If this inequality does not hold, then we repeat these steps until mod of a minus b is less than 10 to the power minus n. Let us make an understanding of bisection method with the help of an example. Find a real root of the equation x minus cos of x is equals to 0 using bisection method. Correctly up to 3 decimal places. We are given that f of x is equals to x minus cos x, and here the value of n is given as 3. That is, the tolerance become 10 to the power minus 3. 3. Firstly, we will try to find the initial interval where the root may lie, and for that we apply intermediate value property. Starting from 0, this becomes 0 minus cos of 0, and this is 0 minus 1 is equals to minus 1. So the value of the function at point 0 is negative. Checking the function value at the point 1, this becomes 1 minus cos of 1. This becomes approximately 0.4597, which is positive. So clearly f of 0 and f of 1 are of opposite signs. Implies root lies between the interval 0, 1 by intermediate value property. For the first iteration, here the value of a is 0 and the value of b is 1. Mod of a minus b should be less than 10 to the power minus 3, but here the value of a is 0 and b is 1, which is equals to 1, and this is not equals to 10 to the power minus 3. So we will find the midpoint. M is equals to a plus b by 2 is equals to 0 plus 1 by 2 is equals to 0.5. Checking the value of function at the point M, which is f of 0.5 is equals to 0.5 minus cos of 0.5, which is equals to minus of 3.776, which is negative. For the next iteration, here the value of function at point M is negative, implies now the root lies between the interval 0.5, 1. Checking the stopping criteria, a minus b is equals to 0.5 minus 1, which is equals to 0.5, and this is not less than equals to 10 to the power minus 3. So we will find the midpoint again. M is equals to a plus b by 2. Here the updated value of a is 0.5 and b is 1. This becomes 0.75. Checking the value of function at this point M, f of 0.75 is equals to 0.0183, which is positive in nature. Moving to the next iteration, here f of m is equals to f of 0.75 is greater than 0, implies the root lies between 0.5 and 0.75. Checking the stopping criteria, mod of a minus b is equals to 0.5 minus 0.75, which is not less than equals to 10 to the power minus 3. So we will find the midpoint again. M is equals to a plus b by 2 is equals to 0.5 plus 0.75 divided by 2 is equals to 0.625. Again checking the value of function at this point M is equals to minus 0.1860, which is negative in nature. So repeating this iteration with the same process, in the last we will have iteration number 14, where the value of function at the midpoint 0.7393 is negative in nature. So the root will lies between the interval 0.7393 and 0.7397. Checking for the stopping criteria, 0.7393 minus 0.7397, this is less than 10 to the power minus 3. So this inequality holds here, implies that M is equals to a plus b by 2, which is 0.7393 minus 0.7397 divided by 2 is equals to 0.7395 is my required root of the given equation. F of x is equals to x minus cos x. Let us go through this question again. Let this be an x-axis and here be the point a equals to 0 and b equals to 1. By the intermediate value property, the root of the equation will definitely lie between this interval, and after finding the midpoint m, the function value at f of a is given negative and the value of the function at the point b is positive, and the function value at the point m is negative. Now by the intermediate value property, the root will now lie between this interval. So in the iteration number 2, we have updated our interval as a is equals to m, which is 0.5, and b will remains same. We will find the midpoint here again. Notice that here value of f of x at a is negative and positive at the point b, and when we have find the updated value of m, which is 0.75, the function here is positive. Now by the intermediate value property, the root will now lie between this interval. So for the next iteration, the value of a will remain same but the value of b will update as 0.75. The function value at a is negative and the function value at b is positive. After finding the midpoint, we have noticed the value is negative here, so the root will lie between m and b. I hope you have made an understanding of the bisection method graphically also. Keep learning.